Welcome to today's deep dive. Our mission today is to explore the chemistry of fire. So we are looking at this really fascinating investigation by two science students, Kesser and Steen, right alongside some of the global research on wildfires.
Yeah, I mean, especially with all the news going around the world right now about wildfires in places like Canada, Spain, and Norway.
Right, exactly. And you are going to find out what Kesser and Steen actually discovered about whether ash is really this miracle fertilizer for your kitchen garden, or if you're just better off sticking to a good old-fashioned homemade compost.
And we'll also get into exactly how they figured out the true pH of this viral ash hack that's been going around.
Yes, which is just wild because usually, when we talk about wildfires, the imagery is just pure devastation. But then you step into the gardening world and suddenly people treat ash like it is absolute magic.
It really is this massive paradox, isn't it? I mean, we fear the blaze, but we kind of crave that sudden fertility it leaves behind.
Oh, 100%.
Because if you look at the fundamentals, fire, whether it is a massive forest or just, a log in your living room stove, it all comes down to the fire triangle. So that's oxygen, heat, and fuel.
Right, the absolute basics.
Exactly. And fire is essentially just a hyper-fast way to mineralize organic matter. It releases carbon dioxide and literally does in minutes what natural decomposition takes years to achieve.
Which is exactly why humans have used it as, like, nature's fast-forward button for thousands of years.
Oh, definitely.
Like, just look at the ancient practice of slash and burn agriculture. Our sources show that early farmers would clear coniferous trees, burn them, and plant rye directly in the fresh ash using just an axe and a sickle.
Yeah, it's pretty intense.
And get this, they were getting a prolific 25 to 100 stalks per seed.
Which is just an incredible historical yield, right? But I think that directly feeds into the modern internet hype we see today.
Well, for sure. People see that historical fertility and think, hey, I can hack this from my own backyard.
Exactly. And that is the exact issue Kesser and Steen ran into. There is this viral trend where gardeners take wood ash from their stoves, mix it with water and sugar in a bucket, and basically try to ferment it into super fertilizer.
But there's a huge flaw there, right? Like, the internet bucket hack completely ignores what part of the tree you're actually burning.
It really does. So Kesser and Steen realized that burning a thick tree trunk is completely different than burning what we call ramial wood.
And radial wood, that's those thin twigs and branches, right?
Yeah.
Like under 7 centimeters.
Yeah, exactly. Those thin branches are basically the tree's engine room, so they are packed with active nutrients like nitrogen and phosphorus. But a thick trunk, that is mostly just structural rebar made heavily of calcium.
Right, so when you burn that thick wood at a high heat, what actually happens?
Well, the nitrogen, which is the main thing plants need to grow, it literally vaporizes. It just goes right up the chimney. So what you are left with in the ash are highly reactive mineral oxides.
And then this viral hack tells you to just mix those oxides with water.
Right. And when you mix calcium oxide with water, it reacts violently. It creates calcium hydroxide.
Oh, wow, okay.
Yeah, Kesser and Steen actually tested this ash water, and they found the pH was staggering. It was between 9 and 10.
Wait, really? So it chemically becomes lye? Like oven cleaner lye?
Yes, it is in the exact same family.
Oh, hold on. I am so confused. If this becomes lye, how on earth is it fermenting? I mean, doesn't fermentation require living microbes to eat the sugar?
Well, that's a thing. They don't survive at all.
Are you serious?
Dead serious. The lye causes a chemical reaction called saponification.
Wait, saponification, like making soap?
Literally, yes. It turns the fats in the microbe cell membranes into soap. So you are basically creating a completely sterile kill zone in this bucket.
That is wild. But wait, people doing this hack claim they see fermentation because the pH eventually drops after a few weeks, right?
Yeah, but that is a complete illusion. What's actually happening is the carbon dioxide from the air binds with the calcium in the lye. It settles out as solid chalk, which is what artificially lowers the pH in the water.
Oh, so it is just dead water.
Exactly. And Kesser and Steen even proved this with an eggshell test.
Right, the eggshells. So when they put eggshells in actual acidic homemade compost, the shells dissolved and released nutrients. But in this basic alkaline ash water, absolutely nothing happened.
Nothing at all. The alkaline environment just locks all the nutrients up tight.
So pouring that basic ash water on your garden is actually terrible for it.
Yeah, it instantly strips away the protective microbial layer that roots rely on to feed.
Wow. So according to Kesser and Steen, what is the better way? how should we actually use ash compared to homemade compost?
Well, their conclusion is to only use dry ash and only in tiny amounts directly in your compost pile. You just have to let the soil's natural acids and organisms buffer that extreme pH slowly.
Okay, so what does this all mean for you and your garden?
Yeah.
Well, the ultimate innovation here is to just skip the fire entirely, right?
Oh, absolutely.
Instead of burning those nutrient-rich twigs, you just run them over with a lawnmower to chip them up, put them on the soil, and let white rot fungi do a natural, slow, cold fermentation.
Right, because those microorganisms specifically break down tough wood. The soil is just a much better chemist than we could ever be in a plastic bucket. It builds structure, holds water, and it respects the natural biological timeline.
Fire might be a phenomenal fast-forward button, but the most advanced technology is actually that slow, natural chemistry of the soil itself.
Definitely, we really shouldn't try to rush it.
Exactly. Which leaves you wondering, if our ancestors relied on the extreme destructive shock of slash and burn for massive temporary yields, what vital long-term soil biology were they sacrificing just to get that short-term burst of growth?